Hello everyone. On our last videos we looked through the Anton equation and the compressibility factors for the equation of states, and today we'll look at another equation of state which is called the generic cubic equation of state, which is much more accurate than Anton equation. And as you can see, it's written as a cubic equation, but here the equation is not in the cubic form, so we'll try to determine the cubic polynomial from this equation in terms of compressibility factor, which is z. So let's start by writing the factors, like writing the equation first. So here we say P equals RT over V volume minus B, which is the excluded volume of molecules, then A, which is related to T, which is the sphericity of a molecule, then V minus epsilon excluded volume, and V plus sigma B. So epsilon is sigma. If we go like below here, these are the assigned parameters for the equation, depending on which method you use. So there are three methods for using the cubic equation of state. So there's a Redlich-Kwong, Redlich-Kwong, and Peng-Robinson method. So they do have different parameters for the equation. Okay, so as we have this, we know that we want to express our polynomial in terms of z, which is the compressibility factor, which is equal to PV over RT, right? So to our cubic equation of state, let's multiply every term by V and divide it by RT. So we'll have pressure volume over our temperature on this side. So for this one, if we divide it by RT and multiply it by V, we'll have V minus volume minus excluded volume. And for this one, we'll have, let's write it as A, that is dependent on temperature. So V over, let's say RT, V plus epsilon beta, V plus sigma B, right? Okay. The next thing we do is let's express this term in terms of z and divide these two to V. So we'll have we can divide these two by volume, both the numerator and denominator. Okay, we say this is equal to z, and here we say 1 over 1 minus B over V, right? If we divide it by V, volume. Okay, if we divide this side by volume, both numerator and denominator, we'll have A RT 1 plus epsilon B over V. But if we look at our second parentheses, thing inside of the parentheses, we see that we're still left with V. So let's divide this again with V. So if we divide it, we'll have 1 V here, and we have 1 plus sigma B over V, right? Okay, so the next thing we can do is, as we have here our equation for z, we can make the V as the subject of the equation. So we'll have z RT over P. So the compressibility factor multiplied by R, which is a constant, multiplied by temperature over the pressure. So if we go down here, we can replace all the V's with this equation we found. So we'll have z equals 1 over 1 minus BP over RTZ minus A, so we have here like v, so we can say like if we move it to the up, we have ap over r squared t squared z over 1 plus epsilon bp over rtz and 1 plus sigma bp over rtz, right? So if we look to our equations, here we are given two equations in terms of beta and q. So we know that if we look here, we can say that the beta is equal to bp, so beta is equal to bp over rt, and we have q, which is equal a over brt, right? So now we have two more parameters, so let's apply these to our equations and try to change it. Okay, so here, if we look here, we have bp over rt, so we can change it as 1 over 1 minus beta over z, right? And here we also have bp over rt, and we also have it here. If we look at the top, we have a over rt, so we can change it like for the numerator we'll have q beta over z, and for our denominators we have 1 plus epsilon beta over z for the first brackets. For the second, we have 1 plus sigma beta over z, right? So now it looks much more simple than we started at the beginning, right? So now let's divide everything by z. So if we divide it by z, divided by z, and divided by z, and let's divide this term by z twice, because we have two z's inside of the brackets. So we'll have, okay, like this would be 1 plus 1, it's not plus, equals 1 over z minus beta, right? And for our second one, we'll have q beta over, like if we divide it once by z and move the z2 down, so we'll have like z minus epsilon beta and z, sorry, it was plus sigma beta, right? So we have our equations and it looks much more simple now. So what we can do now is to give the least common denominator and try to find the coefficients of the terms. So what we'll have is, if we give the common denominator, it's going to be z minus beta and multiplied by this thing, which is going to be z squared plus epsilon plus sigma beta z plus epsilon sigma beta squared, which is going to be equal to this thing again multiplied by 1. So we'll have z squared plus epsilon plus sigma beta z plus epsilon sigma beta squared minus qb beta, like multiplied by z minus beta, right? So now let's have a table for our z squared term, z cubed term, z squared term, for z term, and for the coefficient, like for the term without z. So if we divide this, like if we open these brackets, we have 1z squared, which is going to be positive, right? So we'll put 1. And if we, for the z squared, we're going to have epsilon minus plus, sorry, it was plus sigma. It's going to be plus sigma beta z squared. It's going to be z squared, so this is going to be our coefficient, right? And for that term, it's going to be in terms of z, it's going to be epsilon sigma beta squared, right? Yeah. So if we open this thing, like now we're gonna have, if we divide, like if we multiply everything by beta, we're gonna have minus beta. We're gonna have z in terms of like epsilon plus sigma beta squared, and we're gonna have epsilon sigma beta cubed, which is minus, and this is also minus, right? And if we move to this side, we're gonna have this thing, but as it's another side of our equation, we're gonna include the negative signs, right? So we're gonna have -1, and so this is gonna be negative epsilon plus sigma beta and negative epsilon sigma beta squared. And if we open the last bracket, we're gonna have qbz minus, but it's another side of the equation, so we're gonna have to move it to the left side, so it's gonna be qb beta, but with the plus, right? We're gonna have to, like, it's gonna be a positive number, and minus beta, so we're gonna have plus q beta squared, but when we move it to the left, we're gonna have minus q beta squared, right? So now this is our final answer for our cubic polynomial of, like, so we expressed our generic cubic equation of state in terms of the compressibility factor and found the coefficients for the cubic polynomial. So thanks for your attention.